So if you want to get started with CTFs, you can. I don't know if you're watching this recording. I guess it's a bit too late for you. We have CR3 CTF next weekend. That's the first CTF from that team. Kind of known in the space, but it's happening and we're doing it. Um, we also have a invitation from Bugcrowd company doing bug bounty programs for a hardware hacking workshop. We're looking at doing that maybe the first week of May, around week 5, I believe. So we have that going. And then next week we have the highly anticipated hacking laundry machines workshop, which everyone loves. Uh, Other than that, we got some new infrastructure. We're working on a cyber range, pretty much where you will test all your cool hacking skills in a live environment, depending on what scenario we set up or you want to help set up. This will help test applied cyber skills. So, setting up all your cool, fun stuff like, hey, I want to hack AWS. Well, now is your chance to kind of see that in the real world and, try and get into it. This also lets you set up some production level software. You never touched Active Directory. Well, now you can, and you can hack that as well. Howdy. We have a new CTFE going up because we've been kind of lazy with our current one, and it's been desolate. We're looking for people to contribute to challenge creation, and I will talk about that later. So today, essentially, we just got 3 parts. Current state of cyber in the UC system, our class recap, introduction to hacking competitions, some ambitions, goals, how it went, future of CNPM, whatever, and kind of finishing it off with some design considerations for CTF challenges based on my experience of writing them daily for about 3 months straight. So, fun stuff. Let's get into it. So, going into the current state of cyber, we are terrible at. The UC system is heavily uninvested in anything cyber related, and that kind of sucks. And honestly, I'm not happy about it. Unlike the East Coast, where we have all the cool defense companies and government offices, they don't like investing that stuff on the West Coast. But that's not to say that the West Coast doesn't have any cyber programs. If you think about West Coast cyber, you usually think of CCC or California Community Colleges, where you have things like Cabrillo or kind of like the community colleges down by LA. They have a lot of cool cyber programs. At UCSC, it's just mainly graduate research. We have one upper division undergraduate class, CSC 132, which opens every fall. So sign up for that if you want. Then we have CSC 233, which is the advanced course. That's for graduates. That happens usually in the winter quarter, and last quarter it was on AI and automating security. Pretty fun. There's cryptographic kind of introduction classes, but that's mainly in the applied mathematics department, which in my opinion is boring. And then we have our coolest, newest class, CMPM 17-1, Introduction to Hacking Competitions. Oh boy, that's a fun one. So, yeah, that's the current state of cyber in the UC system, and especially UCSC. So the outlook is pretty much not good. And with that, it leads us to the main problem of, hey, you graduate or you're about to graduate and you're at a point of not being sure how to set up anything or do any real world tasks because the entire time you've been here, you've been taught useless things of how do I write C code or Verilog to pass these test cases and nothing past them. This kind of funny post that really connects with a lot of people that I know personally. It's, they go through 4 years of CS or CE and then they come out trying to do a hackathon because they think it's fun where you have to build up a product in like a weekend. And they don't know how to do that because they've never touched any production level stuff. And in the end, they break down and they can't do it. Not fun. So we want to avoid this. In this case, they didn't even know what a environment variable was. I kind of blame the community college or whatever college they went to for this, but this is how a lot of people turn out. And this is why people say that, having projects is really important when you're trying to get jobs, is it helps you build these skills that we actually use in the applied world. So that kind of goes into the whole, hey, but that's CS, not cyber. Well, even if you're not a cyber major, your role is still very important, mainly in keeping systems safe. Because most vulnerabilities that we find, in the news and big attacks are not from 0 days or these big exploits that everyone makes. They're just simple misconfigurations and bad practice. Those are the root causes of most security escalations nowadays is not someone left, a vulnerable server that could be attacked with one of those, Metasploit payloads, but hey, they forgot like how to filter text properly, or they didn't set up a correct AWS configuration, and now their entire system is compromised because they didn't check that. And before you complain about, hey, this is more of a cybersecurity point of view, well, most of us here are not, cybersecurity enthusiasts. Uh, I think there's only like 4 or 3 people in the club that are actually trying to mainline it for cybersecurity. Um, so don't think this is exclusive. Um, for most people in the club, cyber is just a hobby that they're interested in because hey, they want to challenge themselves a bit more. And knowing this stuff can give you some crazy skills. Configuring services with security in mind is something that your supervisor or, employer would want you to have. So if you're applying to jobs, hey, knowing how to do that is really cool. Having that applied cyber knowledge lets you work with things like Windows or Linux servers, set up, additional services on top of that, and create a project yourself. You don't need to wait for a supervisor to come in with someone who knows more than you. You could do it all yourself and you get extra brownie points if you're especially doing like an interview and you're saying, hey, I have these skills, whatever, things like that. It's pretty cool. So there's that. And taking initiatives, right? So we don't have a good cyber program, so what can we do about it? Well, there's kind of 2 prongs here, right? You have the student-led portion, which is essentially the clubs or kind of slug security, because I don't think there's any other clubs. There's women in cybersecurity, but um, I don't know. I've kind of seen them absent from doing competitions. I don't know. Uh, it's a thing, so maybe check it out. Uh, where in clubs you do competitions, you do projects, you do hands-on practice of cyber, right? Hacking systems, even if it's CTFs, things like that, it teaches you applied skills. And then we have the design, engineer, build class, which we'll talk about later. And then the other prong is, of course, faculty led. Um, I was told that there might be a new cybersecurity class coming around. I don't know. Uh, I got a hint that it was reverse engineering, but I have no idea. That's what I would want it to be because that's my favorite field. But don't quote me on that. But yeah, essentially, the idea is that creating the curriculum should be pretty easy, but applying it in practice should be kind of harder. And as you can see on the top right there, we have a list of all the faculty currently doing computer security and privacy research here. It's very small compared to pretty much every other field we have at this university or department even. So there's not a lot going there. I think officially we only have 2 cybersecurity professors that mainline that field, and so it kind of leads us to go down the student-led path if we want to take initiative of improving cyber knowledge in the UC system, or specifically at UCSC. So, what about our class that I keep mentioning about our beloved Introduction to Hacking competitions? Well, let's talk about it. So, how it started essentially about a year into Slug Security, we've been hosting workshops. We've competed in various competitions, mainly CTFs, a few applied things, but mainly CTFs. And we saw that there wasn't much engagement other than the people with previous experience or kind of closed off community group. We saw people, the same people coming back and, doing these competitions, but no new people really. Um, so one day we got a listing in the Vasta newsletter saying, hey, we got this new revised class, which clubs in the past have used to teach their members skills like CAD design or 3D modeling. And we were very interested in that. That class being CMPM 115. Essentially, you spend a quarter developing a course that a certain set of students will take, and then you teach it the following quarter. And students are given 3 units for that plus a GE, so they have an incentive to take the course without being overpressured by other classes. Because the problem with clubs is people are full-time students and they have to make a decision of, do I go to this club event or do I go to class and possibly risk failing. So there's a compromise of, hey, here's a small little bite-sized class that gives you some knowledge that's approved and vetted, but hey, it also counts towards creating or giving you knowledge in the club, which is pretty cool. And that's what we did. So our ambitions was kind of following how we started with CTFs, or at least in my opinion, how I first started doing CTFs. And in my case, that was Pico CTF in high school. I had no experience with cybersecurity other than kind of general programming. And what ended up happening is, I spent a full week doing all the general challenges on Pico CTF. Um, and really getting into that area. And that's how I started. And essentially, once I was done with one, I just moved on to the next category and kept doing that. I just kept finding more CTFs and completing them. So I wanted a similar experience for students taking the course. So essentially, people come in knowing nothing and they get hooked on the CTF high, as we'll call it. Essentially, maybe they'll end up doing competitions and getting interested in cybersecurity, and hopefully they'll join Select Security because that's pretty cool. And we want that to happen, right? We want outreach. So going on to ambitions, we had a few iterations of how we're going to design this class, and the first was, hey, let's take the CTF concept and cover every single category, including reverse engineering and pwn/binary exploitation. But hey, we realized by feedback that in 10 weeks that was not possible. So the second iteration of this, we were given the expectation that students taking the course would basically know nothing. And I was kind of, disappointed in that, being told that, hey, you need to design this course in the manner of someone who's never touched a computer. And I thought that was kind of ridiculous because how are they enrolled in this course if they've never touched a computer? That is very weird and funny. So essentially, first year and second year students that are completely unexperienced, we decided to go with kind of the more applicable fields, that being basic Linux, forensics, steganography, and web hacking. Because everyone uses websites to interact with various services and whatnot. So I think it's the most applicable rather than teaching reverse engineering or things like that, because they got to go through how does a binary compile, whatever, things like that. And then the third iteration basically chose, hey, we're going to do a set amount of topics. We're going to do 2 weeks per subject. First week should be very basic knowledge on that topic. And then second week, we get into the advanced stuff. And if you look at our statistics for the class, it was actually pretty cool. We had a lot of bio and just like earth science people in our class, which was very interesting to see. And you can kind of see that our spread was mainly in the sophomore area. I'm not a big fan of how limited it was because a lot of people come into the UC system with transferred credits, and this kind of boosts their class standing. So if you're a freshman, you're most likely going to be counted as sophomore because you're bringing in extra transfer credits, and that just boosts your standing, and it sucks. We had a lot of people who were like first or second years who couldn't enroll in the class because they're marked as a junior, which, is kind of terrifying, but kind of disappointed us. But, in the end, it ended up working out fine. This was a class size of about 20, I think 19 or 18 to be exact. But essentially, you can see we have a pretty good spread. We have a lot of CE, CS, but there's bio, cognitive sci, electrical engineering, molecular, and cell biology. Pretty cool. So talking about goals, essentially, I want people to be curious. I really want people to look at something and wonder how it works. More importantly, is it secure? So the example I want people to think after they take the class is they go home and they look at the laundry system that they see maybe once a week when doing laundry and they ask themselves, I wonder how that works, right? How does it process my payment? How does it start a machine? Things like that. And more importantly, can I cheese that and get free laundry for life? Um, and I want that to be applied to pretty much everything in life. Which is more like, 1 through 3, 7 lead hacker thought experiment or something like that, where, you look at everything and you think of it of how can I maybe attack that non-violently, but, how can I hack into it and maybe, learn something new? This not only, increases your technical level, but you can learn some new things. You can learn how things work, and that gives you those applied skills. Going into goals, of course, select security. We need that diversity of different perspectives because, hey, if you're a cognitive sci major, you probably have different perspectives than a CS major. You don't look at everything and see Python or C, or I don't know how CS majors think. Hopefully not in code or whatever. But yeah, and we already have a lot of different majors. This was a screenshot from a few days ago where, we had a new registration sheet come out last week for shirt sizes and whatever. And you can see that there's a pretty good spread of people there. Um, Google had the same idea. They started something called Google Clinics, which essentially provided services for businesses that can't afford cybersecurity personnel to secure their sites and products because they had no money, or they kind of just being cheap or whatever. But essentially, you bring many perspectives or a diverse, uh, thoughts into a group, and you can come out with, some kind of improvement. In this case, a safer system because you were able to spot a vulnerability. Pretty cool. And more importantly, give knowledge to take home. I want people to maybe in a few years, when they're talking, college experience, they were like, "Oh yeah, I took a quarter where I learned how to hack. That was so cool." And maybe at work, at home, in their daily life, maybe they're playing a game, they can use that extended knowledge and do cool stuff, or inform people of something that they shouldn't worry about. It's like someone worrying about, oh, someone got my IP. What am I gonna do? They tell their friend, hey, I took a hacking class in college. I know that having an IP doesn't mean anything. It just means that they can find what your internet service provider is and your zip code, maybe. Crazy stuff. Maybe they talk about dynamic IPs and your IP will roll over if you have that. But yeah, maybe they'll do some cool bug bounty programs. They can make some money professionally or on the side. Uh, there's a lot of bug bounty stuff. Companies want you to hack them for money. So looking into the timeline, it was pretty simple. Essentially, 10-week course plus finals week. It started off really simple. We had icebreakers, some ethics, introduction to Cali, things like that on the first week. Second week and third week was mainly, the basics and advanced side of the terminal and Cali, combining commands, installing packages, whatnot, basically allowing them to be self-sufficient on getting help with commands, things like that. Weeks 4 was mainly for forensics. Hey, metadata is in photos. Be careful about what you share online. You can find out, geotagged stuff. stuff like that. You can look into networks and capture traffic. Week 5 was introduction to steganography, looking at, hiding data in plain sight through audio or images, and we had a midway review. And then the other half of the course was basically 2 weeks of web hacking with a introduction of how websites send data, receive data, do requests, followed by more advanced hacking by, actually looking at flaws in websites and attacking those flaws. Week 8 and 9 was, or week 8 was a introduction to CTF write-ups and a walkthrough of everything we had covered so far, uh, and essentially just some, final details on what the final was going to be. Weeks 9 and 10 were special because essentially we said to everyone, hey, your final is 2 weeks long. Weeks 9 and 10 should be pretty simple because you're doing that final. Give us some topics you're interested in. And people wanted to cover real world vulnerabilities. So we talked about CVEs, SQL injections. We did a bit of, securing your own systems by doing protecting against malware and malware reversing through things like strings, network traffic. Pretty cool. And then we had the finals week, which was just 1 day of presentations, and that was pretty fun. How it actually went was the class structure, very small. So as I said before, it was about 20 people, which allowed for kind of a group or pair discussion, pretty much like high school. It weirdly reminded me of high school just because, everyone kind of knew each other. And I don't know, it felt weird in a college setting to be that close to each other. Classwork, as you can guess, consisted of small CTF challenges, usually 2 per day during class, and that was kind of to also do your attendance because we required attendance or whatever. There's also weekly notebooks, but that's kind of more of a design or iteration thing that the class is built on. So I wouldn't really count it as work. It's just you have to document things you're doing, which is fine if you're doing the work. Some people don't like documenting their work, which is fine. I don't really care too much, but hey, it's what people want. Weekly work for the class was pretty easy. It was just 3 challenges covering weekly topics or themes that we didn't individually cover before, but it required you to do some exploration, or as we say, Google like a hacker or whatever, things like that. And then of course you got to turn in some notes. The midterm and final, basically it was individual work up until week 5, and then we switched it to 2-person teams where both of you worked for its challenges. The midterm was over the span of a week. The final was over a span of about 2 weeks, and it required a final presentation, basically a walkthrough of given challenges. And I think it went pretty well. Kind of the statistics of our class is before the final, they had about 45 challenges completed. Pretty cool. They logged about 600 hours on doing challenges. Again, this is over 20 people over 8 weeks. So it wasn't honestly bad. They covered those 6 categories we talked about, the command line basics, advanced Linux, forensics and steganography, network forensics, basics, web exploitation, and, advanced web hack. So very basic there. And what our final looked like is this is exactly what we gave them. Basically, the requirements was you got to complete a realistic mock CTF competition over the span of about 2 weeks, 17 days, because you have that extra weekend or whatever. They had to get a total of 2,000 points, which is about 20 challenges completed, and they had about 3 challenges in each category they could do. There's about, I believe, 10 challenges in each category, so they had a lot of space to kind of play around. And if they wanted to do, more in one category, they could. And more importantly, they had to do a demonstration, kind of like a DEF CON style presentation of how they walk through a challenge and solved it. Of course, we also require them to do write-ups of all challenges solved because I'll talk about it later, but if you don't do that, people can just share flags and say they completed work. You don't know that, so we asked them to do write-ups and gives good documentation of how they finished their stuff. Uh, Basically, it started March 1st, and I believe it went until I don't know March 18th. Yeah, see, I added 17 to that. I was amazing. And we release challenges in waves so people can't, just go through all of them at once. Or this was rather me not wanting to make a lot of challenges one day because I was making them daily, kind of based on how the class was doing. For the future of CMPM 17, um, there is quite a lot to do. So, season two, as I like to say it, is coming fall 2024. So, if you're interested in taking the class, it'll be available there. We're mainly working on automating systems, mainly scoring engine and kind of learning thing, learning quizzes we have on Canvas. So, first of all, refine challenges. I got a lot of feedback on challenges that I need to go through and I need to look at because I'm looking at people's write-ups. While there is unintended solutions for challenges, there's no wrong solutions, but definitely ways to cheese some problems I've done. Like some people were meta attacking the challenges where they were looking for the flag instead of completing the challenges, and that kind of got to me. I was honestly surprised anyone figured that out. That was fun. Um, and interactive resources for learning via the new quiz system. If you guys didn't know, we use Canvas learning management system here at UCSC, and they have a new quiz system. And that gives us a lot more power of how we can, give people the resources to learn. Uh, if you didn't know, we're gonna make them point out on the picture which button is which. So, kind of proves them uh being able to know what to press or where data is, what looks interesting, things like that. And essentially, we want that to be as automated and as easy to go through as possible. We had some issues with grade limbo where, people like to get their scores immediately, um, which is fun, but also sometimes we can't do because, if you tell people what their score is, they'll just tell their friends, hey, this is the correct answer. So we want to avoid that, but we also want to make it as automated as possible because setting up this class was a lot of work. I'll talk about how many hours I put into put into it personally, and honestly, it was kind of helpful. But to make it easier on anyone who carries on the torch, we want to make it as easy as possible for you. And with that being said, we're looking for people who want to teach the course. As a little disclaimer, if you want to teach the course, you get paid for about 100 group tutor hours and about 20 reading hours. That might be more in the upcoming season or trial run or second run of the class, but hey, if you're interested, contact us. We're told to ask for people who are interested in teaching, so look into that. My personal statistics were very fun. So it was very tolling to create everything. I think if you want to start creating a class like this, or you want to teach, it requires passion, and I do mean a lot of passion. Uh, I made over 110 challenges for the class. These were all personalized for the class that we went over, the class content specifically, and all the learning materials were pretty much custom for the class. I spent over 500 hours into this kind of development cycle. You can see that originally I spent 120 hours during that, first semester of CMPM 17 or CMPM 115 at the top there. And then about 400 hours, during the course cycle of writing challenges, doing all that fun stuff. But yeah, I think the hard work is done for those who wish to carry on the torch if they so wish to. So if you want to, look into teaching this class or teaching cyber, the class content and infrastructure or kind of like the structure of the class is there. And if you want to make a spin-off of it, maybe a different part of cyber, you can. I suggest you do. It's a fun experience. uh, spending 10 weeks teaching people how to do stuff is really cool and gives you some cool presentation skills. Um, my closing thoughts on this is it's a bit limited on topics, right? We have this no prereq kind of rule with the class where you can't expect anyone to know anything, so you can't do advanced. Getting into applied cybersecurity is something I really want to cover. Securing real life applications or services like, hey, we've got AWS, we have Active Directory with Windows. We did a competition similar to that with Slug Security called CCDC and CPTC, where we were given like 10 machines and we had to secure it against people actively attacking the machine. If you're really interested in that, I suggest you do it. People actively attacking your stuff is so fun. We had people playing, duck videos on our things because they got into our computers. It was hell, but we learned so much. And maybe with, oh my God, success of the cyber range we're planning to build, we can have more discussions with faculty advisors and we make more applied cyber classes. So if you're interested in making cool stuff or cool classes or cool content, contact us. Fun stuff. And now we only got about 20 minutes left. I'm going to try and rush through CTF challenges and how to design them. So any questions on anything I've talked about so far in the Zoom from people in the room? You have questions? What's the sentence? You know. Okay, well, if not, let's move on. So CTF challenges, we basically have a very limited tech stack. There's mainly two platforms when we think about CTF challenges that are open to us. We have CTFD and then we have RCTF, which is kind of a newer one. It's owned by Red Own. It's a team that does CTFs and they make their own infrastructure. It's pretty cool. But essentially, everything is hosted on containers, which I'll talk about later. They contain their own database systems for holding files using whatever containerization method they use, buckets, whatnot, things like that. And most of the time, it's kind of based on Python. I know not everyone likes Python, but makes it easy in the back end for newer people. For the tech stacks for the actual challenges, there's a much larger range of things there. For web challenges, we have things like JavaScript based or TypeScript based things that run on kind of Node-ish things. We have PHP with Apache, and we have kind of Python web apps with Flask. So that's pretty easy on the website. For forensics, it's a bit harder because, part of forensics is creating fake network logs, steganography, metadata, things like that. Audio-based challenges, just trust me, try not to do that. If you're going to design a CTF challenge, those are terrible because, first of all, people have to listen to them in class or, in person at a CTF. And some people can't hear well or they can't hear at all. So I don't suggest you do that. So mainly we use, Python. We use libraries like Faker for fake data, Lorem Ipsum, whatever, or Scapy. Those are pretty easy to use unless you're talking about Scapy. That's kind of a very annoying thing for generating PCAPs. And then we have pulling or reversing. Basically, you can do any applied language. This is probably the easiest part because all you have to do is just write something in a compiled language, put in or bake in a vulnerability. Sometimes you have to give them a shared library like a libc or like a standard library that has a set, structure so they can recreate some kind of exploit, but essentially it should be pretty easy. So here, actually deploying it, it's pretty easy. You have mainly four components that you really need to a CTF challenge. You need the source of whatever it's going to be using, right? You need a solution or a write-up, because if you don't have one, it means that you didn't really go through the effort of verifying of the challenge actually working. And we've ran into this issue during some competitions where people were like, I didn't test this challenge before putting it up here. And people get really mad because there's no proof of a actual, uh, you know, proof of concept out there. where you're actually able to solve the challenge, and it honestly sucks. You need to include a distribution folder, which is essentially files that people will get or some kind of generation files. And then you need some kind of containerization. This could be Docker, only Docker I can think of right now because we don't use Kubernetes for this stuff because that's kind of overloaded. Uh, but yeah, I guess just a Docker file just so you can containerize whatever thing you're doing, whether that's a website, so people can't really, mess around on other people's instances. They get their own stuff. It's pretty cool. And then to make it all nice and organized, you can use something like CTF CLI, which essentially makes it really easy to sync between CTFD instances and backtrack to any mistakes because you can put version control on, you know, CTF challenges. Most importantly, test your deployment. As I said before, you have a solution or a write-up that you need to include in your things. Make sure when you deploy it, you can actually run through that challenge solution and it works fine. You don't see any mistakes. I had a few times where my challenge solution was fine, but I didn't push something and I didn't test the deployment. And my students are like, hey, this is the wrong flag because I forgot to include the correct flag in production. Um, and that kind of just bums people out because you're supposed to make a seamless experience. So our current CTF infrastructure, don't mind these names. Pringles and Pandora are two machines, VMs on a machine. We have machines inside machines, but essentially we have multiple CTFD instances currently. And the idea is that Pringles or machine one is on a secure network, right? This is where all the personal information, like, hey, your login details, your email, stuff like that, your scores, if you're in a class, because that is considered privileged information, because, grades are considered private data and we're not allowed to share them, whatever, things like that. So that network has to be secure. So our solution, just in case someone wants to be funny and break out of our secure environment, is we have everything running on a separate network. And how we connect the two is we use a Docker API. We say, hey, Docker is running on this other computer. Go talk to that computer about spinning up a challenge and forwarding ports. And that's how we're going to do it. We have a box called Pandora because that's kind of a fitting name of Pandora's box. There's unknown or untested waters with the security there. Perfect place to put challenges. And essentially, each one of those three CTFD instances for each service we run, we have multiple. We have one for the club, we have one for CMPM, we have one for CSC 132. They can just contact that server and say, hey, can you spin up a secure instance of this Docker container? And it will do that. Either if it's a web challenge, it will securely make that and give it a nice, kind of wrapper, things like that. So people can connect. And if it's a reverse engineering or a PON or binary exploitation challenge, which requires people to hack a running program, we can have that more securely contained in case someone wants to break out. Because doing that, and someone breaks out and they get access to your actual system is terrible. Even though, we don't know any active container escapes, maybe they'll make the first one and target us. I don't know. It's a good idea to separate it. So designing the actual challenges, you have to put some considerations. You have to limit yourself when you're making these. You can't go too broad and make it about multiple things. In our case, we want one theme per challenge. Otherwise, if you don't do that, you should probably state that, hey, this is like multiple categories or whatever. In addition to that, it should be pretty bite-sized. As we talked about before, you want to kind of have them addicted to completing these challenges. We want them to feel that CTF high of, hey, I solved this challenge. I want to solve another one and essentially keep them going. This is how people learn. And I think it's a really cool thing. Maybe don't take it too far. This is why we do rolling CTF releases so people don't do them all at once and controls it. So have them addicted, but not too much. And then, of course, the higher they progress, the harder it gets, the more points they should get, things like that. For our class, we didn't do that because all work is kind of equal. Other than the final, we kind of use weights there instead, so we didn't need to worry about that. Additionally, I think something that a lot of CTFs miss is applying a real life theme. When you do a CTF challenge, you're there to learn some kind of skill, whether SQL injections or whatever, things like that. People should think that this can happen in real life, and the one way you do that is you make it look real. Um, and of course, it could mean that they start hacking real systems, but hopefully not. Hopefully they just see that and they say, "Hey, I can connect this to the real world." So that means, first of all, creating fake data, garbage data like random hello world, blah blah, fake, dev you random stuff. Uh, make real looking data. And as I said before, you can use Python libraries like Faker or other services, whatever, to do that. Put real names, things like that, or fake real names. Don't put real names, put fake real names, not just garbage. And learn from feedback. People, you know, want feedback on their work, and CNPM really allowed us to do this. Um, and as I said before, use Docker for everything. Make sure your ports are random. We didn't have this during CMPM where we had web challenges, and when someone spun up an instance, what would happen is the next instance that was spun up would just take the current port that Docker made and just add one to it. So it kept iterating. So what someone could do is they spin up their own instance and they just plus one or minus one from the port range and they get access to someone else's instance. So be random with that, make it look real. Um, so here's an example of a kind of cool example I did for one of the final challenges where I remade a quote unquote uh, testing, self swiping feature for the dining hall where people could just swipe their cards, or in this case, they type in their cruise ID and they quote unquote swipe their card. Um, but quote unquote, they find this web page through a network scan. They find it and they realize they can do a cool SQL injection on it and extract all the data in the database and get everyone's cruise IDs, how much money they have, some common stuff like that, and essentially clone that system. And that's what I mean about making it feel real. Is you make realistic connections. In this case, it could be just images or how the web page looks, but something that doesn't look garbage. And I think I did a good job on this. Some retrospectives, some things I learned from designing CTF challenges throughout the last quarter is forensics by far is the most annoying category to make challenges for. If you incorrectly make a challenge for forensics, specifically a network log, Wireshark will cry that something's out of order because, network captures are very specific. If something is out of sequence, then that data packet essentially is useless and you're gonna get a failed connection or whatever because a certificate didn't match or a checksum didn't match, whatever, things like that. So Wireshark will cry. And for a simple uh PCAP file for Wireshark, which is a network log file, I probably spent about 300 lines of Python just to make it work. And I think that's ridiculous for a forensics challenge, something that would take someone like 10 minutes to solve. So I really suggest looking out for that. For web hacking, it's more of a challenge of making your site look real, but once you get some kind of design going, I think it's kind of easy. If you're doing the route we're doing, which if you're wanting to contribute to this, you need to consider this. We currently have people connecting to the same IP, just over a different port, right? You have maybe a challenge that's spun up for one person on this port, and then they go to another web challenge. It will spin up on a different port every time they click a new instance. The issue with this is that cookies will save if you're using the default like Flask or Apache or whatever configuration, they will save because it's the same IP and you're just connecting over a different port. So they have that going. There's a way to kind of fix that, but if you're lazy and you don't notice it, people will have cookies that will last from one site session to another, and they need to clear that. Otherwise, they'll get confused why it's there, and they'll think that, hey, it's part of the challenge. I'm supposed to look into this in instance. Source code wise, you need to intentionally comment if you're going to give them source code of maybe what's important, especially for beginners, because they'll get stuck on the smallest thing. If you give them a source code, which I did, for a Flask environment, which is a way to host a website using Python, whatever, things like that. Um, and you use something called sessions, which makes a secure session token based on a secret key, which by default is generated using random every time the container starts, which is secure. And there's no way of breaking it because it uses some secure JWT, whatever nonsense. They will try and break that because they don't understand it or they don't kind of do enough research on it. And, that leads them down to a rabbit hole and they're just talking to a wall. And that goes on forever until you tell them, hey, you should maybe look at something else. For Potent Rev, this is the most dangerous category. Most people in CTS try and do a container escape, which is scary. So you really need to lock that down, and there's libraries for that. So I wouldn't suggest tackling this as your first thing. Maybe looking at local files or things like that is probably the best bet. For the web hacking source code, this is what I mean. People don't really read things, and sometimes you need to just highlight it here. In this case, we're using Flask sessions to make a secure session cookie, right? So what happened here is this secret key is the same, right? And as you can see, all my different things are highlighting it in my code editor because it knows that, hey, this is incorrect, but they're not programmers, most of them, so they didn't see this. So when they were looking at the challenge, they were like, this must be secure. I might as well just look past this or whatever. So I had to add comments that, maybe highlighted in things like Nano or Vim or whatever text editor they're using, hopefully. But essentially, they'll get caught up in that. And a big thing is things like environment variables. There's a lot of ways of setting up backup variables if, a environmental variable isn't found. Like in this case, we're getting flag, but if flag doesn't exist, we're getting this other fake flag or whatever, things like that. So that's an issue. People will get stuck on that. So you really need to comment out, especially if you're doing it beginner style of, hey, this is, I don't know, some satirical comment on, oh man, I hope no one exploits this or whatever, things like that. Essentially, that's what you should look at. We had another dumb idea, which I did, is we had issues of allowing people on our network for the machine that everything was running on, where we had a firewall rule of, hey, only some stuff can, come out, whatever, things like that. So I had to write this dumb bash script that would auto start every time the computer started to make a UFW rule to allow the Docker container to open up the internet and, allow connections. This was super dumb. And hopefully we don't need to do this in the future because we'll have better firewall rules. But hey, it exists and I think it's ridiculous. So, consider not being like this, but it was pretty fun. And kind of the future of CTF challenges, you really shouldn't trust anyone. I know, students are meant to be trusted or whatever, but you really want individualized flags for everything and everyone. This includes challenge artifacts, things you download. Pico CTF already does this, and we kind of want to do the same thing. People are less likely to flag share, even though they still can. Explain how they solve the challenge. But we already do this with challenge HMACing the flag in our current CTFD infrastructure for binary and things like that. But I believe it asks for your username. So that's kind of bad because it should be an automatic flag, at least compared to now. CTFD has that where it automatically knows what, user ID is connecting because it made a instance for you on a new port or thing like that. So honestly, I think that's the way it should be done. You want to make it a very painless experience to do challenges. And for quality of life, we're planning to add rating and feedback plugins for CTFD and containerization to level CTF, as I said before. So for future, we want to make more fun challenges, right? We want people to learn. For the CTF that the club runs, we want to allow user-submitted challenges where it's not just officers writing challenges, and not just normal challenges of, hey, here's a website, hack into it. We want to maybe do some more applicable things of, hey, maybe you can spin up this network instance with two quote unquote computers sending data. Can you join in as, another computer on the network and, figure out what they're sending? This might require, open VPN configurations, things like that, whatever. But hey, it's like try hack me style of a more applicable learning environment. And if you're interested in this stuff, hey, we have projects in the club. If you're interested in doing those, let us know. It's mainly Python work, maybe some networking. Let us know. Should be fun to do. Next week, that's pretty much it for CTFs. I'm running out of time, so I'm trying to finish it up. Next week, we got the coolest thing. Oh man, that took a while to load. We got the most fun workshop ever. Hacking a multi-billion-dollar laundry company and how to report vulnerabilities without getting into trouble. Essentially, pointing out that the emperor is buck naked, and not being sentenced to death by his guards or whatever. So if you're interested in that, hey, we have a Discord. You can scan that QR code or go to slugsec.ucsc.edu/Discord. If you're not registered already, you should do that. slugsec.ucsc.edu/join. There's a lot of ways to connect. And we've hit our time limit. It's 6:30 p.m. It's right on the dot. I think I did a good job. And that's it. Any questions from the Zoom, the crowd, the audience, my fans, my friends, my family, my fam? Well, if not, thank you for coming and, hack the world. Woohoo.